So 5.3 is all about taking the derivatives of inverses. So the first thing we'll do is we'll talk a little bit about what inverses are and a couple of their rules. So we're going to let the inverse of f be g of x. So now we're not going to talk about f of f inverse. I think it's easier to just talk about g of x as being the inverse, because it's not really a -1 power, even though that's what it looks like. All right, so whether you remember or not, a function does something, the inverse undoes it, or vice versa. So if you start with x, you do something to the function, and then you undo it, you get right back to x. And this is true of any two inverses. This is actually one of the proofs that two functions are inverses, is when you take their composition in both directions, you should get x. All right, so the goal is we want to find out what the derivative of the inverse is, g prime of x. So we take the derivative of both sides, so we have to use a chain rule. F prime of g of x, so the derivative of the inverse times the derivative of the inside, g prime of x, equals 1. Okay, so then the derivative, g prime of x, is 1 over f prime of g of x. Now, a couple things that we have to be careful about here. A lot of times people want it to, it's a little bit more reversed than you really think about here. So the g of x, it's not talking about really an x value. So it's the y value of g of x that we're plugging into the x value of f, if that makes some sense here. So what a lot of people think is it's f prime of x, but it's not really the x that we're getting, because a lot of times they're going to find f prime of 3. Okay, well, the problem is that f inverse prime of 3 is not an x. If we're talking about the inverse, it's actually a y value. Now, a couple things that we note, that inverses have reciprocal slopes. They're symmetric about the line y equals x. So that's where we get this reciprocal. But the one thing that we really have to be careful about is this is just generally going to be a y value that they give us. So when you get this, you're going to set it equal to f of x, not plug it in for x. And that's one of the biggest parts. This is used in multiple choice questions a lot of times. I would say if you can find the inverse and then take the derivative, that's probably the most straightforward way. But if you can't, this is the way to go. So let's see a couple examples here. Before we get to the examples, let's go over our steps. So the first thing is you want to find the x value of the original function by setting the function equal to the value we're looking to find. So that's along the lines of, well, right here. We're going to keep the same thing that g is the inverse of f. So this would be x normally, but since it's an inverse, x and y switch. So when we go back to the original function, we're not going to find f prime of 3. We're going to find out what x value it is. So we set 3 equal to this. And then work on it from there. All right, so now once you have the x value, you find the derivative of the original function. So you're going to do the derivative, and then you're going to find the value of the derivative at that point. Okay, so first thing we got to do is we got to solve this equation. And sometimes you can solve it by hand. I don't think you really can in this case. So what we can always do is we can always solve it graphically. So we got 3 equals 1/4, and if I want to go set it equal to 0, so 0 equals 1/4 x cubed plus x minus 4, and now I can use my root button on the calculator. You could also set these equal to each other and find the intersection between the two. All right, so let's take a look at that. So go to the calculator. In my y equals, I got 1/4 x to the, what do I have, to the third, plus x minus 4. I'm looking for this is equal to 0. Now, if you remember, inverses only really work if they pass the horizontal line test. In other words, when you do the inverse, it won't pass the vertical line test. So I'm hoping that this passes the horizontal line test. As a matter of fact, I know there's one value in the book where it doesn't pass the horizontal line test, but they still kind of expect you to do it, which is kind of strange. So when that comes up, I can't remember which value it was. I think it was the one on the right that you really wanted to use. But this is the point that we're looking for. That would sure help if it was 2. So I'm going to just guess 2. I'm going to trace 2. See if it's 0. Yep, it's 0. Good stuff. If it was like 1.98, it would be a much harder problem to actually do out by hand. Okay, so the x value that we're looking for is really 2, not 3. That's the y value. If I was to plug in 2, I should get 3 here. So that's the first step, is to figure out what the x value actually is. When you're given the inverse, the x is actually the y. That's the one thing to realize about inverses, that x and y switch spots. Alright, so now we want to use the derivative. G prime of 3 is going to be 1 over f prime of 2. That's really what you want to do. So we got to figure out what f prime of 2 is. So f prime of x is going to be 3/4 x squared plus 1. Okay, so we went 1 over 3/4 times 2 squared plus 1. Well, that's a 4, and the 4 is going to cancel out. So we end up with a 3 plus 1, or 1/4. Now, one of the things you could possibly do here is you could always find the slope at x equals 2. So if I get my calculator, I could always use my second trace, find the slope, which is 6, at 2, and it gives you 4. Now you got to discard this 0.00003 business. It's just rounding errors that didn't round, and you take your reciprocal of it. So you do it that way too, but you want to be able to show your work. All right, let's show you one more example. Oop. Just a little bit here. Well, let's do this natural log 1. Then maybe we'll do the AP problem at the bottom here too. All right, so G is the inverse of f. That's always good. Example before, I didn't really mention that, but it was assumed from earlier. And so the first thing we got to do is we got to set 1 equal to ln of x. And so that happens when x equals e. Okay, so what we want to do, g prime of 1 equals 1 over f prime of, not the 1, but the e value, the x that we found. Remember, this is a y value in an inverse. Alright, so what we have to do is we have to take f prime of e, so f prime is going to be 1 over x, and plug in your e. The 1 over on the top is just from here. It's my derivative, so you get 1 over e, or e. And that's really it. It's not that hard of a process to do, but it's kind of like a double flip. First off, you gotta realize this is y, not x, and so you switch it around. And then not only are you going to do the derivative at that point, but you gotta flip it. All right, let's look at the AP problem at the bottom here, and then we'll call it a day. All right, so we have f of x is here. We have g is equal to the inverse of f, so g of 2 equals 1. What is the value of g prime of 2? Now, we got to realize here is normally we set this equal to 2, so x cubed plus x equal to 2. But this being number 27, so early on, you can't really use your calculator. And that's kind of tricky to solve. But they do tell me that I got this. Not only this is x and y, but since they're the inverse, this is the y for the original function, this is x. So what I want, I know the x value as 1. Think about this. If I plug in 1 cubed plus 1, that equals 2. Oh, it checks out. So we don't have to do this first step because they give it to us. What we do have to do is g prime of 2 equals 1 over f prime of 1. That's the key. So we have to realize that we're not using 2, we're using the 1. We're using the y value on the g, on the g to get our x value on the f. Okay, so 1 divided by f prime would be 3x squared plus 1. Okay, so now that we've got 1 over 3x squared plus 1, we have to plug in our 1 value. So 1 over 3 times 1 squared is 3 plus 1 is 4. So we get our 1/4. Now this 1 over 13 here would be if you used 2. So if you use 2 here, you got 3 times 4 squared is 12 plus 1 is the 13. If you didn't flip it here, you get this 13 over here. If you use the right value but didn't flip it, you get the 4. Where I get the 7/4 from, I'm not particularly sure. I'll have to have 5 answers. But all 4 of these kind of make some sense. Alright, so remember, you gotta look for the x value. If you get your inverse, they're going to give you the y value. And so you gotta use your x. And then you're also doing the reciprocal of the derivative.